That brings us to the next talk, which is on identifying problematic randomized trials. And this work was led by Kylie Hunter, who's part of my team in Sydney. Just your take-home message here, which Kylie prepared. So yeah, IPD is much better at enabling detection of integrity concerns that are not visible in publications. And she's now published a tool that enables you to do that quite easily. I'm not sure how much you've all heard about the integrity crisis, but it's certainly something that's a big problem, with some estimating that up to a third of all trials have something seriously wrong with them, so are fraudulent or so bad that you shouldn't include them in your evidence synthesis. There's been lots of really high-profile cases, but that may only be kind of what's on the surface, top of the iceberg. So seeing all of these headlines come up, I asked myself, how do I set the integrity of data for my IPD meta-analyses? Thought it'd be easy, but while there are lots of emerging tools, none of them looked at IPD, which may be something we experience quite often in this field. And I found that quite weird, because I've heard previously that IPD is kind of the way of finding these trials. Some even going as far as we should only ever be looking at IPD in meta-analysis, because that's the only way we can detect problems with trials. I know that others in the room disagree with this, such as Pete, but let's just leave that out for the purpose of my talk right now. So the power of individual participant data in assessing integrity. This is a quite fascinating study by Carla et al. He's one of kind of the leaders in the field on integrity, and he's also editor of the journal Anesthesia. And he looked at a sample of trials in his journal, and this is what they looked like when he only looked at the publications. So most of them looked okay. A few had somewhat flawed data, and there are very few what he called zombie trials, so fatally flawed. However, because he was the editor, he managed to get access to all the IPD. And that's what the trials looked like once you had raw data. So almost half of trials were somewhat flaws, and almost a third were fatally flawed. So usually outright fraudulent. And this is something that's also been shown in other fields. It wasn't the easiest one. It is quite problematic. It's not alone in that field. So for that reason, we aimed to develop a tool to look at IPD. And we used our kind of ICON study as a case study for that, but we've since applied that to quite a few other IPDs as well. This is how we developed the tool. So Kylie was very thorough, I think, in first doing a literature review, mapping of existing items. So people were already doing this with IPD, but no one had done it systematically and developed a tool. And we also integrated what checklists of aggregator trials were doing. We then had an expert advisory group that helped us refine the tool, piloted it. We also tried to validate, so we had journal editors send us trials that they felt had integrity issues, and then we matched them with other trials and blinded them, and had kind of some students use the tool on these different trials and see how many they detected. And we also had AI make up some data sets for us. So we kind of went through these processes, and we are planning on kind of continuously updating the tool as well. And this is what it looks like, the tool. So what I'll now do is I'll just briefly talk you through the different items in case you're interested in using it. And then I'll give you a couple of examples and let you rate the integrity of those. So we have kind of at the bottom here are the different checks. We have both aggregate data level domains and IPD domains. And I think that's what makes it so powerful, really having the combination of the raw data and the publications often enables us to see things that you wouldn't see based on the publications alone. And these are the different parts, so the components of the tool. So we have the instructions and decision guides down here. We have a rating sheet, and we have an automation script. So you have to set this up once, and then it can run on each of your trials that you include in the IPD quite automatically. So it's actually quite quick to run. Once set up, it takes us about half an hour per trial, and that's something we can run alongside data cleaning and risk of bias assessment. That doesn't really add that much time for how much you gain by maybe throwing out some trials that have serious problems. So instructions, tells you when to use the tool, how to rate each item, and how to make a timely decision. So when to use the tool, I think that's quite an important one. So whilst we designed this having IPD meta-analysis projects in mind, we also now think it's quite useful when you're doing an aggregate data meta-analysis and there are trials that just seem a bit sketchy to then maybe request the IPD for just these. And we've also had journal editors send us trials or contact us to use the tool when they had trials where they just weren't quite sure whether to include them or not in their journals. So I think the application is wider than just IPDMA. We have instructions on how to rate each item and how to make a final decision on whether to include your trial or not. And this is not always clear. So I think when integrity concerns first emerged, we often heard the message, you'll just know if something's fraudulent. And there are some trials like that. But we also have quite a few where we're somewhat unsure about, where we have to make a decision. That's why we never really label a trial as this is a terrible fraudulent trial. We just say it doesn't pass our threshold of integrity or something along those lines. And we are actually also thinking about maybe there's some trials that are grey enough that we may want to do sensitivity analysis with them rather than straight up excluding them. And then that's the automation script, just to briefly show you. It's quite, I think statisticians have done a really nice job at having the kind of a vignette here and making it quite intuitive and adding good instructions, but I may be biased as well. All right. And then it will give you pretty outputs like this, a report for each trial that has some graphs and some statistics. For example, here, this is randomization per day of week. That's always a nice one. So what you'd expect is for most trials, they're randomized less on the weekends and otherwise quite uniformly across different days. If they do the same on a Sunday as they do on a Tuesday, it's often a problem unless they're in kind of an emergency situation. Right. And then there's the rating sheet, just to show you. That's in an Excel, and you rate each domain. And just to bring you back to our case study, so in ICOM, we included 3 out of 64 trials because they clearly had integrity concerns. Now, there were quite a few great trials that we didn't exclude because we were quite conservative back then. We've actually had a letter to the editor to our publication saying we didn't exclude enough trials. So there's a lot of heated discussion going on in that field. But yeah. I'm just giving you a couple of examples because I always think that's fun. So I'm going to make you rate. And anyone who's seen this before, I think Wendy, Richard, and Pete, please don't rate. So, so this is correlations. So one thing we're looking for is are expected correlations present in a data set. And for example, in ICOM, we want birth weight and gestation age at birth, because these are preterm infants, to be correlated. So the earlier babies born too early, the more correlated. Now, these are 2 real trials. I'd just like you to have a think about which of these trials is problematic, trial A or trial B. I'll give you 1 second to look at it. And now you can raise your hand if you think trial A is problematic or trial B. Okay, luckily you've all listened. And one other one. So patterns of allocation. So this is showing us, again, who's being randomized into the control and who's being randomized into the treatment group. And now the question, is that problematic or not? If anyone has any thoughts or comments on this? Who thinks this is problematic? Yeah. So most like looks like something went a bit wrong there with our randomization, right? And we don't know if that's maybe that may not be that they've been fraudulent. It may also just be that something went wrong with randomization software, or someone found out how to randomize and putting patients into a certain group, or maybe the treatment just was available a bit late at some sites. But that may also then inform our risk of bias or data quality rating. All right, and here I think I've already shown you this one, but do you think this one's problematic or not? Who thinks this is problematic? I really think it may be. Again, I randomized a lot on the weekend. Not clear though, because that was also quite a small trial. So that this would possibly be something where I'd say these are some minor issues. If everything else is fine, I may let this one through. If I find lots of other things, I may see this as an indication. All right. So that concludes my little exercise. Yeah, so in conclusion, we have the IPD integrity tool. It'd be great if people wanted to try it out and use it. We're always happy to hear feedback as well to make it more accessible and easier to use. Just a few things I get asked a lot. So I've basically already tried to preempt all the discussion we may have. But yeah, isn't it too much work? I already mentioned, I think 30 minutes is not so much for the fact that you may throw out trials that are completely useless. Like the kind of data sets we've seen where it wasn't clear at first, now we did this checklist, quite shocking. Yeah, who would be silly enough to share fake IPD? Great question, people do. We also do see a lot of integrity concerns in the trials that don't share their data. So I think, again, I know Richard has developed great methods for combining IPD and other data, but we're being quite careful now about which trials that don't share we still include in our synthesis for that reason. It's another thing we may want to discuss. And I think another few things that I like to, oh, by the way, this is my dog reading the IPD handbook that I printed out. I don't know if she got much. And yes, some more things that we are kind of thinking about that'd be great to talk a bit more with you about is how do we then deal with untrustworthy studies in a collaboration. So that led to the editor that we got also accused of us of not being transparent enough because we didn't list the studies that had integrity issues and the reasons. So whilst everything else we publish and are transparent about, if someone shares their data with us, we're not going to break that trust by then saying this study is fraudulent or have integrity concerns. So we keep our integrity ratings confidential, but that obviously also has problems. It's really difficult to decide how strict to be. And I am quite worried about AI. So the data sets we created with AI were actually the hardest to detect. I mean, they also didn't have publications, which hopefully that's where we would find things as well. But we quite, particularly when you know what this tool uses, and then you create a data set, AI can kind of get around that. So something really to think about further, I think. Right, and that's it. That's Kylie, who actually did all the work. So you'll have all the credit.